Alright, I'm going to make a very quick video over inelastic collisions. In an effort to entertain you, hoping more will watch it, I've made some pretty cool animations here and came up with a pretty neat story. So what we have here is in an inelastic collision, we know with elastic collisions, so for example, if this were an elastic collision, maybe this would hit and bounce off, and then they would both maybe go off in different angles. But in an elastic collision, they bounce off, and they don't get crumpled up. There's no deformation. They don't crumple up. They don't get wrecked. They're fun. They're just the same. Just like, if I take two billiard balls and hit them against each other, as long as I'm hitting them at fairly normal speeds, they're not going to be deformed really. They'll just bounce off each other in an elastic collision. In an inelastic collision, they don't bounce off. They stick together is the big difference. So inelastic collisions, they stick together. Let me try to give you an example. Let's imagine that there's a ninja, okay, and this is their ninja star, right? So it spins around as they toss it through the air. And oh wow, that stopped. Anyways, and then we have a heart here, a beating heart, right? So imagine that this ninja star is gonna smash into this heart, right? So if I throw it really fast, like a ninja, then what will happen is these two objects, you can imagine this star is probably going to get embedded inside of that heart. Sorry if that's too grotesque, but that's what would happen, right? And then these two objects might move together. They're no longer going to be two separate objects, but instead we'll group them together. They're just one object now. And they move together. This is a perfectly inelastic collision when they stick together like that. But we still know that the conservation of momentum is still going to hold true. So let's imagine that before they collided, I'm just going to kind of make up some numbers real quick. Let's say before they collided, this star, okay, for the star has a mass of 1 kilogram. And it was moving at 4 meters per second. We also know the heart has a mass of let's say 2 kilograms. Alright, so this ninja star is going to hit into the heart. Well, before it did that, so when it was over here, I combined them together so that I can't anymore, but before it hit, the total momentum, and it's just a one-dimensional problem, was 4 kilogram meters per second. What that means is after the collision, the total momentum later still has to be 4 kilogram meters per second. But now they stick together. So the question is, how fast do they move after the collision? How fast is the heart going to fly away now with the ninja star? Well, we know that momentum is mass times velocity. So we still know that the total momentum after has to be the same before, so it has to be 4. So we have 4 kilogram meters per second is equal to the mass times the velocity. Well, this has a new mass, and you can probably figure it out, but you've got one mass over here and another mass over here. Well, they're stuck together, and now they just have the total mass. You just add them together. So it's sort of like m1 plus m2 times v, because they move together with one velocity. So of course we have 1 kilogram plus 2 kilograms times v. Well, in other words, I'm going to write up here because I'm running out of room. 4 is going to be equal to 3v. V is 4/3 meters per second. Or in other words, that's I guess 1.3 repeating meters per second. And that's how fast the ninja star and the heart will move away together. So in an inelastic collision, these two objects will stick together. And we can do two-dimensional problems, which we'll probably do tomorrow, and one-dimensional problems looking at them in an inelastic way. Thanks for watching. Remind your friends to watch before they end. Well, before class tomorrow, I guess. See ya.